Good day, we are going to look at equilibrium today. We are basically looking at question 1991, question 6 of 1991. Equilibrium. Equilibrium is something we encounter every day in real life. In physics, in fact, in so many areas of branches of science, equilibrium is dealt with. Today we'll be looking at, we're looking at a static equilibrium, which has got to do with rotational equilibrium and translational equilibrium. The rotational equilibrium has it that if a body is undergoing rotational equilibrium, the sum of the moment about any point in that body should be equal to 0. For translational equilibrium, the sum of the horizontal component should be equal to 0, the sum of the horizontal component equal to 0, and the resultant, of course, equal to 0. This is an example of a static, translational equilibrium. How do you go about this problem? There are so many ways you can go about this problem. How do we do this? I think Lamy theorem, if we use Lamy theorem, it will simplify this question a lot. How do I mean? T1 over sine of this angle opposite it equals 100 Newton. This is 100 Newton over the sine of the angle opposite it. Very, very easy. Very, very easy. If we had, if it had been T2, we are looking for, we would have just resolved this one vertically to equate it to 100 Newton. So we go T1 over the angle there is 60 plus 90, which is 150 over sine 150 degrees equals T equals 100 Newton. We don't need 100. We don't need this one because it's also no 100 Newton over sine. The angle there is 120. 30 plus 90 over sine 120 degrees. So we have T1 over sine 150. Sine 150 is 0.5. These are some of the special angles we should know. For 100 over sine 120. Sine 120 is root 3 over 2. So we have let's simplify this further. T1 0.5 equals, multiply the whole thing by 2, 200 over root 3. So that gives us root 3 times, or simply T1 is 0.5 times 200 over root 3, which will now give us 100 over root 3. 100 over root 3. Do we have any? Okay, we have 100 over root 3. So our answer is simply B. T1 in the diagram is 100 over root 3. So let's simply go to the next question. 1983, question 3. Consider the following forces acting at 0 and they are in equilibrium as shown in the figure above. Which of the following equations are correct? P1, this is theta 1, this is theta 2, this is P3, P1, and then P2. Which of the following are correct? Can I quickly get that on the board? Okay. Okay, that's it. P1, P2, is P3. So for this system to be in equilibrium, the sum of the horizontal components should be equal to the sum of the vertical components. The horizontal components are what? Simply, we resolve this one horizontally, we resolve this horizontally, that will give us P1, the sum of the horizontal components. It means P3, for the horizontal component, P3 should be equal to P1 cos theta 1, theta 1 plus P2 cos theta 2, which is this. So this gives us a horizontal component, which we have as one of the options, 3. And the horizontal component, what of the vertical component? P1, the horizontal vertical component gives us P1 sin theta 1 equals P2 sin theta 2. P1 sin theta 1 equals P2. So simply, we don't need to beat about the bush. The answer is simply 2 and 3, because P1 cos theta 1 equals is never correct. It's not one of the conditions that must be obeyed. So our answer is 2 and 3. So we have D as an answer. So thank you very much. Next time we have much more time to deal with some of these questions. Thank you. Bye.